Okay, so in this question, what we're doing is we're combining the two concepts. On your paper, you have the Earth and you have a moon. And really what's going to happen is we're going to be in orbit. So this thing will be going around the Earth in an orbit like this. Now the question is why? So this first three questions tries to lead you into solving the mystery. And the mystery is why it's turning. So is the moon experiencing a centripetal force? Well, yeah, it's turning. If it wasn't experiencing a centripetal force, it would be turning. So what is the evidence? It's turning. Anything that's going in a circle has to have a centripetal force on it. So that's the clue to first of all. And then the next one says, well, how are we going to solve this question? Well, you need to know that the centripetal force, which is this direction, um, is actually caused by gravity. So that's supposed to be a G. So this one, what's the name or cause of centripetal force in the moon? That's gravity. Gravity's causing that. So there's our force vector arrow, which is right there, and I drew in it and I labeled it. And then I'm going to show the work on the paper showing the amount of force pulling on the moon. So I can either solve for Fc, which is this equation here, Fc, or I can solve the same thing for Fg, because what we're saying is Fc and Fg are equal in this scenario. Now this is not always true. This is true in the case where the Earth is going around the Sun. It's true in the case where the Moon is going around the Earth. It's true for any type of orbit like this. Fc and Fg are directly related, but it's not true, for instance, for a car going around a corner. Your steering wheel does not control gravity. Your steering wheel does make a centripetal force, but your steering wheel does not make some sort of a gravity steering wheel. It's just the wheels, and the wheels provide friction. So this is only true in the case of this idea where we're orbiting something. So instead of doing Fc, we're going to do Fg, because Fg is the one that we have all the information for. So this is simply going to be G times, man, I'm doing some mess ups on my writing here, G times M1, which is the mass of the moon, times M2, which is the mass of the Earth, divided by the distance from the Earth to the moon. So a lot of people, and that's squared. So a lot of people get that messed up because this distance right here is the radius of the big turn, this big orbit. It's not the radius little r of the Earth. It's not the radius tiny r of the moon. This radius here, this distance, is from the Earth to the moon, right? That distance here is the distance of the orbit, and that's the circle we're talking about. So we're got to be using the same idea of this is the distance between them. It's the circle we're talking about. So that's that distance. Don't worry about the radius of the moon. Don't worry about the radius of the Earth. Just worry about the radius of the turn. So this will give you your force. That will give you your gravitational force. But you also got to know that they are the same. Fc is equal to Fg. What is the type of velocity the moon has? Well, if you look here, if I don't give it a velocity, it's going to look like the moon is going to be pulled straight toward the Earth, but it's not. The moon actually is going to be going sideways with a tangential velocity at the same time as it's pulled inward, and that's why it goes in this orbital path, because of these two things acting at the same time. So we can solve for V by saying, okay, since I know what Fc is now, and I know what the mass of the moon is, V squared is what I'll solve for. So I'm going to solve for that V, and that will give me how fast the moon is, and that'll be a true answer. You could look it up on YouTube, Wikipedia or whatever, and it will tell you that that is truly the correct velocity of the moon. Now, it's an average, so it's going to be pretty close, but whatever you look up might be off by a couple, 10 or 15 meters per second, but not by that much. The last one catches everybody. Right? The acceleration is always in the same direction as the force. So if the force is to the center, the acceleration must also be to the center. And what is acceleration? Acceleration is just Newton's second law. Newton's second law said acceleration is always the force divided by the mass. The force you figured out in this part, and the mass obviously is the mass of the moon, and you'll be done. Force divided by mass. And that's how we solve this question. It's a great review of the entire unit.